Okay, so as we roll into Chapter 5, it'll be pretty quickly apparent the importance of Chapter 5 when we start talking about reactions and numbers and being able to calculate how much product is going to be formed or how much reactant you need. So I think Chapter 5 is pretty apparent of its importance, but let's look at an example here. That's a pretty good example, right? In 1989, the United States started seeing airbags in cars, and initially the airbags were just in the steering wheel to keep the driver from smacking into the steering wheel and getting seriously injured in a collision. Since then, obviously, airbags now are throughout the car. You have the side curtain airbags, you have passenger airbags, lots of airbags, because we realized having that cushion is a lot better than slamming into a hard surface. They've definitely saved tens of thousands of people's lives over the years, so I don't think we're going to see airbags going away anytime soon. But one of the main issues in airbags is being able to detect the collision fast enough and then being able to inflate the airbag fast enough that the driver or whoever doesn't slam into a surface, right? Initially it was so the driver didn't hit the steering wheel. So there needs to be a way to inflate that bag very, very quickly. And it just wasn't going to happen using, stored air somewhere or something like that. So what finally was determined that was going to happen, they would use this compound called sodium azide. Sodium azide will decompose very quickly into sodium metal and nitrogen gas, and it can create a lot of nitrogen gas very quickly, and the only thing you need to do this is a little bit of heat. So if we have sodium azide in a system that can be heated really quickly, that might have a filament or something in it, that sodium azide can create nitrogen very, very quickly. So what happens is in the airbag, you have some sodium azide and a little filament, and when the sensor in the front of the car senses there's been a rapid deceleration, it sends a signal to that filament to heat up very quickly. It heats up very quickly, the gas is produced, and the airbag fills, all before the driver hits the steering wheel. All right, so we can see that having knowledge of this reaction here is critical. So we know how much nitrogen is going to be produced from the amount of sodium azide that we have. It needs to be enough nitrogen to fill the airbag, but not overfill the airbag. We don't want it to pop, or you don't want the airbag to get really hard, because then you're hitting another hard surface. So having this balance, knowing how much nitrogen is being produced from the amount of sodium azide you have, is really important. And we can see that in this chemical equation that we've got here, where we have sodium azide reacts to form sodium and nitrogen gas. We can see there's a bunch of things in here. There's numbers in front of the reactants and products, which we'll talk about. There's these parentheses associated with each reactant and product, which we're going to talk about. We're going to talk about being able to write these equations for chemical reactions. We'll talk about how we use them to predict how much product is going to be made and all that. All right, so that's what this chapter is all about.